These are the answers to Unit 5 Multiple Choice Quiz A. Questions 15, 9, 10, and 13 were problems for both classes, and then 2, 6, and 8 were issues for separate classes. As usual, I would suggest that you read the question and attempt it again before watching the answer. All right, first question. Following graphs show the sampling distributions for two different point estimators, x and y, of the sample population parameter. And then they ask you to find the true statement. If you look at the statements A through E, most of them involve bias, so it's good to review what biased or unbiased means. Unbiased means that the mean of the sampling distribution is equal to the parameter. Well, if I look at estimator x, the parameter is right here. Since this distribution of samples is symmetric, the center of the samples is the same as the population parameter, which means unbiased. Same thing happens here. Here's the population parameter. The samples are symmetric around the population parameter, so the mean of the samples is the same as the population parameter, so both x and y are unbiased. Second one, online news source reports that the proportion of smartphone owners who use a certain operating system is 0.216. Two simulations will be conducted to create a sampling distribution of the sample proportion from a population with a proportion 0.216. Simulation A has 1,000 trials, sample size of 50. Simulation B, 500 trials with a sample size of 100. The key to this one is organizing everything. First of all, you have to notice that the sampling distribution that they're talking about is for a sample proportion. Second thing is that the population number, the parameter is 0.216. Since that's a proportion, it gets pi. And then organizing simulation A and simulation B this way. A had 50 trials, A had a sample size of 50, and B had a sample size of 100. A had 1,000 trials and B had 500 trials. Usually that's not terribly important, so I wrote it down but very lightly crossed it off. And then the questions ask you about the centers. Choice B is the right one. Centers will be approximately equal and the variability of A will be greater than the variability of B. The centers are the same. And then the variability comes from this formula. When you go to the formula sheet, some people are confused by whether to use binomial or this section here. The reason why it's not binomial is because binomial tracks a count of successes. And in this case, we're talking about proportions. So we're not counting something, we're looking at the percent or the proportion of something that's correct. So we went to this section here, which says for one population, and these are proportions. One thing I want you to notice is that while our book uses pi and p, the formula sheet for the AP test uses different notation. We have pi here, they have p. For samples, they use p hat, and we use p. So it's a little bit confusing, but if you use pi and p notation on the test, the AP graders are perfectly fine with that. They understand that different books use different notation. Which of the following must be true for an estimator of a population parameter to be unbiased? Third one, this one is basically asking you for the definition of unbiased. Okay, unbiased means that the center of the sampling distribution is the same as the parameter. Notice there's no mean over here. Whatever you're measuring is a parameter. It's a single number. Most of these get thrown out because when I talk about variability of the population parameter is a single number, so it has no variability. So these two really don't make any sense. Population parameter, whatever the center number is, doesn't fluctuate. So those don't make any sense. In B, we have this phrase expected value, and that's a very common vocabulary word that you should know. The mean is the same thing as the expected value. So the mean of the estimator is equal to the population parameter. Yes, that's the definition of unbiased. Okay. Next one, samples A and B were selected from the same population. The mean of sample A is equal to the mean of the population. Which of the following statements must be true? So what's happening here is that somebody got lucky. You took a sample and the mean of that sample was the same as the mean of the population. That doesn't happen all the time. Okay, it can happen, but it doesn't happen all the time. So that knocks out option 3. Just because one sample has a mean doesn't mean the next sample is going to have the same mean. So this one isn't necessarily true. Okay. The mean of sample A as a point estimator and the mean of sample B as a point estimator are perfectly valid statements. So Roman numerals 1 and 2 are acceptable. The third one is not. Correct answer is D. Next one. Mean and standard deviation of the sample data collected on a continuous variable y are negative 0.5 and 0.5 respectively. The table shows relative frequencies. This question is asking about shape. As soon as it asked about shape, I drew a display of the distribution. Okay, I took intervals from -2 up to 1, separated by 0.5, -2 to -1/2, -1/2 to -1, etc. And then I drew relative frequencies up to those heights. Maximum was 0.25, minimum was 0.1, and I got a shape of the distribution. Since it asked about shape, since it asked whether or not the shape was normal, D is the one that makes the most sense because this distribution does not indicate a bell shape. Okay, the other ones are incorrect for a variety of reasons. Some of the relative frequencies equal to 1 has nothing to do with shape. Symmetric doesn't necessarily mean normal. This is symmetric, but that doesn't mean that it's normal. So B is probably the closest wrong answer. And then C, center, and E, sample size, aren't really related to shape, except when using the central limit theorem, and that's not being used here. Next one, distribution of the amount of water used per wash cycle in gallons of a particular brand of dishwashing during a cycle is approximately normal with a mean of 4 gallons and a standard deviation of 0.2 gallon. Which of the following is close to the probability more than 3.75 gallons are used? This is a calculator question. If they tell you that something is normally distributed with a mean of 4 and a standard deviation of 0.2, the notation is this. The question says more than 3.75 gallons. You want to know the probability that you pick a value that's bigger than 3.75. So on a bell curve, we're looking for the area to the right of 3.75, centered at 4 with a standard deviation of 0.2. If you go to your calculator and the distribution menu is normal CDF, if you've got a newer calculator, you type in these. If you've got an older one, you're going to type this long statement. But basically, you want normal area under normal curve from 3.75 all the way up to a very large number. I picked 9999. Center of 4, standard deviation of 0.2. Spits out that answer, which is this one here. Okay. If you're given a z-score, you don't have to put these last two numbers in there. You can leave these two out, and then your calculator defaults to 0 and 1. But this was not a z-score. This was an actual measured value for number of gallons. Last question. An advertisement firm reports that the proportion of consumers who respond favorably to a certain advertisement is 0.7. 3 simulations are run, and you have to match up the simulation with the sample size and put them in order greatest to smallest. Sample size influences the spread of the sampling distribution, so I looked at the X scales for all three of these. This had the widest scale, 0.5 to 0.9. The second widest was this, 0.6 to 0.8, and the narrowest was this one, 0.68 to 0.72. As you increase the sample size, the variability decreases, so the narrowest spread gets the largest sample size, so I drew a big N here. The widest gets the smallest sample size, so I drew a small N there, and then this one sits in the middle. So when they say least to greatest sample size, I need to go from A to C to B, which is choice B. Okay, that was kind of a lot. Hope that helped. If not, you can watch it again and test yourself again, but I thought we went with a picture of an adult female jumping spider. You're welcome.